Hello everyone. Today we'll do a very important concept that is the moving coil galvanometer. So we'll do the principle. We have it says when a current carrying coil is placed inside a uniform magnetic field, it experiences torque. We'll do the working and theory for the same. So we'll take L and B to be the length and width of the coil, and also F be the angle it makes with the magnetic field. So we have the torque experienced by the coil, we know BINA sine phi. We'll take the angle as phi. We'll write it as BINA sine 90 minus theta. Get BINA cos theta, as it is connected to a spring. So for equilibrium, we take deflecting torque is equal to restoring torque, and restoring torque is equal to K phi, and we got deflecting torque is equals to BINA cos phi. In this part we have this as phi because we know theta plus phi is equal to 90 degree. K is the restoring torque per unit. We finally get I is equals to K phi upon NBA cos theta. So this was the principle and the working for moving coil galvanometer. We'll also do a topic that is radial field. Says field in which whatever may be the orientation of the coil, but the angle between the plane of the coil and the magnetic field remains 0. So we get I is equals to K phi N B A, where we write I is equals to G phi, where G is the galvanometer constant. We have some other things in this too, that is sensitivity. First, we'll consider current sensitivity. So, what is the definition of current sensitivity? It is defined as deflection in galvanometer on passing unit current through the coil. So we have current sensitivity is equal to phi upon I is equals to NBA upon. Next, we'll take voltage sensitivity. So it is defined as the deflection produced in galvanometer on applying unit voltage. Deflection on applying unit voltage. Right. We have phi upon I is equal to NBAR. So we multiply R on both sides. Sorry, we have K here and we multiply R with it. So we get phi upon V is equals to NBA K R. Capital R, that is the resistance. So this is voltage sensitivity and this was current sensitivity. Next topic that we have is conversion of galvanometer into ammeter. The topic is conversions. Conversions. First one is galvanometer into ammeter. We'll draw the diagram. This is our galvanometer. To convert the galvanometer ammeter, we connect a resistance with the galvanometer, that is known as a shunt. S. We have current I coming from this side. It goes Ig and I minus Ig. Ig is the max deflection. Zero to I is the range of ammeter that we'll get. and we know S is the shunt resistance. So we get, basically we connect the shunt resistance in parallel of the galvanometer. So we get Ig into G is equals to I minus Ig into the value of resistance that we need to connect to convert it into an ammeter is given by S, which is found like this. Ig is the maximum deflection shown by the galvanometer. G is the galvanometer constant and I is the current that is passed. Second one, before we connected the galvanometer in series in parallel, now we'll convert the galvanometer into a voltmeter. So we'll connect the galvanometer and the resistance in series. So we get V is equals to R plus G into Ig. So this is it. We have covered the principle of galvanometer, the working theory, radial field, current sensitivity and voltage sensitivity, and the two conversions, that is converting galvanometer into ammeter and converting the galvanometer into voltmeter. Thank you, and I'll see you in the next video.